Now, what does a resistor do? Well, a resistor is called a resistor because it resists the flow of current in a circuit. And we can use resistors to reduce the current in a circuit, and we can also use it to reduce voltage in a circuit when we use what we call a voltage divider. So we will be looking at those things a little later in a future lesson to show you the practical uses of resistors and why we need to reduce current and reduce voltage in circuits through their use. But basically, remember we studied conductors and insulators? Well, a resistor is in between those. A good conductor is 0 ohms resistance. So if I tie my leads together, I should have close to 0 ohms resistance. And then a good insulator is infinite resistance. And that's when my meter shows open lead. And we've got infinite megohms of resistance. So resistors are in between these two values of 0 ohms and infinite ohms to be useful for our purposes. Now we're going to look at what a resistor does. A resistor resists the flow of current in a circuit. And what I'm going to do now is show you how these resistors resist the flow of current in a circuit. But before we do that, there's a handy mathematical law which is called Ohm's law. And Ohm's law states that the current equals the voltage over the resistance of a circuit. And current is usually represented by I and voltage by V and resistance as R. So we say I equals V over R. So now in this case I am going to measure the current using my 6-volt battery. I've got a 6-volt battery connected. I've got the negative terminal connected here, and I've got the positive connected to this side through my meter, and you can see I've got milliamps. So now I'm hooked up to the 100 ohm resistor, and my battery is roughly 6.4 volts. So 6.4 volts divided by 100 ohms should give me 64 milliamps. And I'm not quite reading that. I'm getting about 57 milliamps. And there's a couple of reasons for that. And the major reason is the fuse that's inside this ammeter for the digital multimeter is also a resistance. So I've got a series resistance of that resistor, so it's making my current a bit less than what we theoretically should be reading. But now we're going to move on to the 1000 ohm resistor, and now the internal resistance of the meter will have less effect. So now Ohm's law tells me the current for a 6.4 volt battery divided by 1000 ohms should be 6.4 milliamps. So now we see we're reading much closer to what we expect mathematically. Here we see 6.283, so roughly 6.3 milliamps. Now we'll move on to our 10,000 ohm resistor. So now we read 0.622 milliamps, and theoretically we should have 0.64 milliamps with a 6.4 volt battery source. And now I'm going to change my multimeter from the milliamp scale to the microamp scale, because when we use Ohm's law for 6.4 volts divided by 100,000 ohms, which this one is, brown, black, yellow is 100,000 ohms. So now we should have, instead of telling it in milliamps, we're going to be reading in microamps. So in microamps, we should have about 64 microamps. So we'll measure that, and look at that. We've got 64.28 microamps. And now our last resistor is a 1 megohm or 1 million ohms resistor. So 6.4 volts divided by 1 million ohms should be 6.4 microamps. And so we're getting 6.26 microamps, which is very close to the theoretical. And remember, these resistors were not exactly the value that the color bands tell us, because they have a plus or minus 5% tolerance. But this shows how, as the resistor gets bigger, the current gets smaller. So that's the end of this lesson.